Good morning students. Consider the next unit, that is straight line. So it's very important part. Maximum number of theorems and examples will appear in this unit. First, definition of a slope of a line. Slope of a line, here AB is a straight line which inclined the x-axis at an angle 30 degree. Straight line makes an angle theta, so that theta in between 0 to pi with the positive direction of the x-axis. Here it makes an angle with 30 degree with respect to x-axis. Then theta is called, so this angle theta, that is theta means here we are considering as 30 degree. So theta is the angle of inclination of the line, so that itself is represented as slope of a line is represented as m equals to tan theta. Here theta value is 30 degree, tan of 30 degree, so it's a trigonometric angle. You are studying this in trigonometry, that is tan 30 is equals to 1 divided by root 3. Okay, so therefore the slope of a line is represented as m. Next one, parallel lines. Parallel lines, so if the two lines are parallel, so we are represented as theta 1 is equals to theta 2. Tan of theta 1 is equals to tan of theta 2, that is slope. Slope itself is represented as m1 equals to m2. The two lines are parallel, its condition is m1 equals to m2. Once again, the two lines are parallel, its condition is m1 equals to m2, so it implies that the slope of the two lines are equal. Okay, next, what is the condition in related to perpendicular lines? Suppose the two lines are perpendicular, so here this is theta 1 is equals to 90 degree plus the theta 2, so it implies that exterior angle, so this is exterior angle, this angle is equals to sum of the two opposite interior angles. Exterior angle is equals to sum of the interior opposite angles, that is theta 1 is equals to, so this is theta 1 is equals to 90 plus theta 2. These two are sum of the two interior opposite angles. Then the condition for the perpendicular lines are m1 into m2, that is the product of the two slopes m1 into m2 is equals to -1. Here only thing you have to remember is if the two lines are parallel, the condition is m1 equals to m2. Suppose the two lines are perpendicular, then the condition is m1 into m2 is equals to -1. Okay, so consider an important theorem, so that is slope of the line joining the two given points. Slope of, here we have to find the slope of the line joining the two given points as x1 y1 and x2 y2. Okay, consider the straight line AB. So this is the straight line AB with respect to x-axis we are considering. So this is theta is the angle inclined by this straight line with respect to x-axis. Okay, this here we have to draw the perpendiculars AL and BM with respect to this x-axis and AN perpendicular to BM. A having the coordinates x1 y1 and B having the coordinates x2 y2, inclined at an angle theta with respect to x-axis as shown in the figure, such that, so m, that is slope, means we are considering as tan theta. Okay, so these are the perpendicular lines drawn with respect to x-axis. After drawing the perpendicular lines, we get a right angled triangle. See here, this is ABN, so it's a right angled triangle. Tan theta is equals to BN, so that is BN divided by AN, that is opposite side divided by, so that is base, so that is AN. BN can be written as, see here, this BN is equals to BM minus MN. Out of this BM, so if you remove this NM, so you'll get BN, so that is BN is equals to BM minus NM. Next, this AN is equals to LM. This LM can be written as OM minus OL. this LM can be written as OM minus OL. Okay, this LM is equals to OM minus OL. Then in related to x-axis and y-axis coordinates are here BM. BM means what? BM. So this is y-axis and this is x-axis. BM means, so y coordinate is y2. So therefore in place of BM we are writing as y2. Next AL. So this is also y-axis, so that is y1. Y2 minus y1. Next OM. OM means, see here, this is OM. OM coordinate is x coordinate, so that is x2. So we are writing as x2. Next OL. So this is OL, that is x coordinate. Here it is x1. Therefore we are writing as x1. Therefore it becomes y2 minus y1 divided by x2 minus x1. Tan theta, that is slope of the line joining the two given points, tan theta is equals to y2 minus y1 divided by x2 minus x1. That tan theta itself is represented as m equals to y2 minus y1 divided by x2 minus x1. Okay, so in related to this equation, one simple example, suppose the two given points, if the 2 points are given, how to find the slope of the line joining the two given points? Here the two given, find the slope of the line joining the points 3 comma minus 2 comma 7 comma 5. Consider the given points as x1 y1 and x2 y2. x1 y1 and this is x2 y2. Formulae, so already we find that the slope of the line joining the two given points is y2 minus y1 divided by x2 minus x1. Here x1 y1 and x2 y2 are given. According to that, y2 coordinate, here y2 is 5 minus of y1 means minus 2. Already minus sign is there, minus of minus 2 divided by x2 minus x1, that is 7 minus 3. So we'll get as 7 divided by 4. Therefore the slope of the line joining the two given points is given is 7 divided by 4. Okay, so you have to prepare this theorem. So that is the slope of the line joining the two given points. So it's an important theorem. It is given by the formula y2 minus y1 divided by x2 minus. So this is the construction part. Just by seeing the diagrammatic representation, so you can explain this only by simply considering this right angled triangle. So here explaining this tan theta equals to bn by n. So from the diagram, what is this bn? Bn means bm minus nm, and this lm, this an is equals to lm. Lm can be written as om minus ol. Okay, that is y2 minus y1 divided by x2 minus x1. Therefore the slope of the line joining the two given points is given as m equals to y2 minus y1 divided by x2 minus x1. So it's simple theorem.